All right. Well, thank you for having me. Beautiful space, and I'm very excited to chat with you today. The focus of the talk is really around consumer crypto at the end of the day. And we're going to talk about a couple problems that underlie consumer crypto apps today, the Web3 services behind them, sort of the different components that go into answering the question, why do we not have excellent alternatives to the Web2 services that we use as consumers, but that are Web3 native, and try to talk about how attributable faults, how we can expand the space of attributable faults, and in general, just problems that lag starting new Web3 projects, like decentralization and what we'll call the cold start problem. All right, so to give a little bit of background, there's been a lot of really good discussion so far today about the background of existing Web2 services and Web2 services that affect our lives in substantial ways. There's always been criticisms, especially among the Web3 community, that we would like to have these applications or versions of these applications that are trustless, that are decentralized, where you can own your own data, you can have more control in the algorithms behind these services. And so that's really a lot of the ethos behind what we're going to try to solve for. And so if you look at these services and you said, I want to build a Web3 version of one of these services, underpinning those services or those applications are a variety of different complicated technical services like databases, storage systems, compute systems, distributed systems. And in the Web2 world, folks have excellent options to build these systems. In fact, even Facebook was built by a freshman in his dorm because the open source stack was so robust and easy to use. But it's actually very difficult to build these alternatives in Web3, and so we're going to talk about why that's the case and what we can do to accelerate that process. So in the Web2 world, folks have a ton of choices of platforms to build on. They can build on centralized cloud systems. They can build with lots of robust infrastructure options. They have easy-to-use platforms. They're all very secure. They're low cost. It's not so difficult to build these complicated systems on the modern cloud in the Web2 sense. But the one thing that is very difficult to build on the cloud is to build these in a trustless way. And so that's why what we're spending our time on in Web3 is really rebuilding a lot of these services from scratch. And let's take a quick inventory of what that looks like so far. There's been a tremendous amount of effort over the past 15 years to build these powerful Web3 services. And there's a few services that we've really nailed. We've nailed payments with Bitcoin. We've got compute solved, at least in terms of EVM-style stack-based compute. And there's a lot of storage options. But there's more components in the stack that need more work. General purpose compute, AI inference, messaging, database networking. These are all things that there's a lot of people building in this space, building really innovative solutions. But it's difficult to build great solutions in this space. And we're going to talk about the reasons why it's difficult to build those solutions and how if we can help solve some of these problems, we can make it easy for the next freshman in their dorm room to build a Web3 version of their social media app. So a way to phrase this that our CEO, Sriram Kannan, uses often is how to increase the rate of innovation and the rate of coordination for people building these Web3 services. So that's what we're going to focus on. And there's two aspects of this problem that we want to focus on. One is what we're going to call crypto economic security. And the second is what we're going to call a cold start set of problems. If I want to build my new Web3 service, what are the challenges that I have just starting from scratch? What am I going to face? And personally, I love the concept of decentralization. It's one of my favorite topics. It's the reason that I spend my time in crypto and Web3. But I'll avoid using that term, trustlessness and decentralization, for this conversation to be a little bit more specific. And I'll instead use the term crypto economic security to mean the same thing, but it will have a different sort of connotation to it. And so let's define crypto economic security as the maximal profit that someone could extract from attacking the system. And that should always be smaller than the minimum cost and force on the system. Basically, we want to make it not profitable for someone to attack the system. It's very different in AWS where the infrastructure is guarded. You can't get access to the system. In this case, the system is open. You can always get access to it. But we want to make it financially disincentivized for that person to go after attacking the system. So let's talk a little bit about cold start problems. So I want to start a new network. We'll call it WestChain. And as I'm starting WestChain, there's a few challenges that I'm going to run into. First question is, how am I going to bootstrap a network of operators? Am I going to have to go to people in crypto and go on Twitter and say, hey, become an operator on WestChain. It's great. Come hang out. You can be a validator on WestChain. That's a difficult process for any project starting from scratch. Also, there's a capital cost for those operators. If I'm going to bring folks onto this new network, that means that they're not operating a different network, and so I need to at least make it profitable for them. I need to pay them a significant amount of yield. So for me to start from scratch, it's a very expensive proposition. And then even further, depending on the network that I'm building, specifying a specific amount of security could be a very nuanced or difficult thing. If my network in WestChain, the goal of it is to generate AI-generated cat images, I probably need very little crypto economic security. But if the purpose of my network is to secure wrapped Bitcoin and $1 billion worth of assets, I'm going to need a lot of crypto economic security because it needs to be more secure than the cost of someone attacking that network. So one solution that we spent a lot of time on is what we called shared security to overcome these two cold start problems, and particularly shared security for services. There's been a lot of tremendous work. I mean, this technology is building on the shoulders of giants. If you look at Cosmos and the Polkadot ecosystem, they really developed this technology in a robust way. But we're going to take a slightly different stance, and we're going to approach it in the scenario of services. So these services that we're building on this system do not need to be blockchains. They simply need to be validated. So to give a little bit of context, before we talk about shared security, let's look at what the world looks like without shared security. In this scenario where we're trying to bootstrap a network from scratch, I've got my service that I'm trying to start. You have your existing service. I have my set of operators. Your network has its other set of operators. And same for the capital base, the folks that are actually securing and staking in that network. This is what we mean by separate economic security, particularly for folks that may have not seen these restaking or shared security platforms in the past. A shared economic platform like EigenLayer or Cosmos or Polkadot means that we are bringing the capital together in one ecosystem. We're bringing the operators together in one ecosystem. So if I want to bootstrap an operator network, or if I want to access capital to secure my service, it's already available. It's ready to go. It's nearby. Now, when we build this service on shared security, bless you, we're going to call it an actively validated service because it's going to be constantly checked. It's going to be constantly validated and look for any faults in the system. So we're going to call it an AVS. And in this world, there's just three simple actors. There is the restaker, the person that has capital, and they want to put that capital in the system. They want to stake it because they believe in the value of this network and they want to be able to earn returns from their capital. There's the operator, the person who's very good at running infrastructure. They don't necessarily have to have the capital themselves, although sometimes they do. And they're just in the business of helping run these networks. And then there's the AVS developer, the person who has this idea. They want to build this new service, this new awesome AI inference engine, which is going to be a core service to help us build better crypto-enabled apps. And so how is security shared, in this case, of EigenLayer's implementation of shared security? You have the restaker, who's going to delegate their capital to the operator. Now the operator has their skin in the game as well as the restakers. They're going to opt in to the AVS service. They're going to run it correctly. They're going to be verified constantly. And if they do it well and properly, they're going to get rewarded on chain. It's going to be verified in a very deterministic way. But if they perform maliciously, they're going to get slashed. And this is very similar to a lot of actively restaked blockchain services. The consumer, who's actually not in this picture, though, is an important piece because they're the person who's going to be consuming from the application. And so what we're trying to build, again, is a marketplace for trust, open trust, not just necessarily for blockchain validation, but more broadly, a marketplace for trust. Because if I'm building the Web3 version of Twitter or Facebook, I do need that trust to build my service that's going to underpin that application. So the second problem that we want to focus on is previously, the scope of what could be verified was somewhat narrow. It was more so things that happen on chain. And in fact, if I want to build a neat AI service or a database service, those are very complex systems. They're very difficult to verify on chain. So how do we expand the scope of what can be verified on chain? And this is probably one of the more interesting problems in the space. I spent the past year prior to EigenLayer at Protocol Labs building decentralized compute ecosystems. And one of the challenges we always had was, what are the different ways to validate that compute was done correctly? If I'm asked to generate cat images, but I actually generate a dog image, who's going to validate that? How can we have a blockchain-based system that can enable that? So if you look at the chart here, on the left-hand side, we start with objectively attributable events. Objectively attributable will be anything that happens on the blockchain. A certain transaction occurs, a certain amount of money is moved. These are all objective, they're deterministic, you can verify it on the chain. However, there's a much bigger space of problems that we really care about, and we refer to those as subjective issues. For an Oracle price feed, what was the price of Bitcoin yesterday? Was it $1? Was it $60,000? It's very difficult to prove that fact on chain. And so a lot of those use cases for Web3 services that we care about fall into this space. And so we're using a new term here very intentionally. The new term is intersubjective verification. Subjective, meaning that it's someone's opinion. It's, is it hot in this room? Yes or no? Who is the president of the European Union? It's a subjective opinion. It's difficult to verify on chain. But it's also among multiple people. So in this room, we can have a shared opinion about how hot it is or how cold it is, and that's our intersubjective opinion. And that's going to form the basis of solving this problem of how do we expand the scope of verification for Web3 services. So now, if we all have this opinion, this intersubjective opinion, how can we apply it in a self-enforcing way so that it's more trustless and it's more blockchain native? And how can we give some cost, if someone comes in and disagrees, we have to associate some cost so they don't constantly blast the system with false challenges. But we also cannot fork the chain. If you go back to Ethereum's history and the DAO and the fork that happened, that was a very costly event for the Ethereum chain. And it was a social consensus that said, we at this point disagree in the state, we think it was hacked, so we're just basically going to overwrite and fork the chain. So we want to avoid forking the chain. Now, what's interesting is you have correlation of two interesting events. You have social truth, which is, we care about something that we can all identify as a cat image or a dog image that was generated in AI. And then also the valuation of a token is equally subjective. If I told you, when Bitcoin forks, and there's been various Bitcoin forks, people have made financial opinions about which fork they want to follow, so that those two each have kind of their own dynamism. So if we can combine those two without harming the underlying chain, we can fork a token instead of forking a chain. We can get a lot of really interesting outcomes. Now, this idea is not entirely new because there are folks like Augur, there are UMA protocol, there is Claros, a bunch of adjudication courts that have done a really good job of bringing subjectivity on chain in various capacities. The way that they approached it was a little bit different for us because we really are concerned about universality. When you fork a token, that token may need to be held onto for a long period of time by token holders. It may need to be leveraged into a DeFi position, so you don't want to destroy the value of that token, but you also want the flexibility to be able to folks to make intersubjective opinions. And so what we can do is we can have a dual token model. We can have an Eigen token, which can be used freely for anyone, and a unwrapped version of Eigen, we'll call it backing Eigen in this case, which you can fork. You can openly fork, and you can let each AVS and each service that has a difference of opinion, if a cat image gets generated when it should have been a dog image, you can fork that token, and we can build really smart dynamics to get the best of both worlds. And so that's the goal of the Eigen token. It's meant to be a universal intersubjective work token, applicable for any Web3 service. And the subtitle of the paper is towards an openly verifiable digital commons. And Ethereum and a lot of the popular blockchains are digital commons. But what we're trying to do is bring more and more scope to what can be verified now on that digital commons. And so it is meant to be universal. It could be applied to all different types of use cases. isolation so that whatever happens in the forking mechanism, you still get the benefits of the financialization of it. We're going to impose a metering cost so that if someone chooses to have a forking action, they can't simply spam it with no cost. They have to put some skin in the game to say, I think there needs to be a fork. And lastly, the very interesting component here is compensation. Uh, when slashing happens in a lot of systems today, the amount that's slashed just gets burnt entirely. It just goes away, which is a good disincentive for the person that was behaving maliciously. But in this case, we can actually send that compensation to the person who was harmed rather than just burning it. So if I am a consumer and I say, I really need generated images of, AI-generated images of cats, and there's some operator in the network that is only generating AI images of dogs, and they have some stake associated with it, and everyone agrees that they're creating images of dogs, that stake that they had put into the system can actually come back to me if I challenge them, and it's verified amongst everyone they were generating dog images. So the harmed party, which would be me as a consumer in this case, can be remediated using this model. And so that's really the goal, is to accelerate the innovation in Web3 services. All of these difficult problems that have been plaguing a lot of our systems that we're building, we can now start to verify those using intersubjective verification. And hopefully, eventually, we can help contribute to building fertile ground so that people can build these fun consumer crypto apps in Web3. And so that's all I have for today. For next steps, please do check out the token white paper. Also, our CEO, Sriram, gave a really good talk about this in much more depth at SBC 24. But also, please feel free to try building your own AVS. All the source code's public, and it's available to try out. And you can follow my team at Build on Eigen. That's all I have for now. Thank you so much.